but I'm trying to get this one done a couple of different times, so that's the reason why it's already filled out some of it. All right, so this says consider a circle with a radius of 5 and another circle with a radius of 3. Let D represent the distance between the two centers. We want to know how many intersections there are of these two circles from the different values of D, which is the distance between the centers. Draw the figures for each case. Okay, so if the distance of 8, so in between here is 8, right? Well, if I draw a radius of 3 circle and a radius of 5 circle, they could at least touch at one, or at most they're going to touch it once. Okay, at one point, because that's the very maximum that they can go. Well, if the distance is 10 between these two, okay, well, this one's only 3, and this one's only 8. I'm sorry, this one's only 5. I'm going to erase that whole thing, yep. This whole thing is 5. That doesn't add up to 10, so it can't touch. Okay? Now, what happens if D is 1? Well, if the centers of the circle, and this one's a little bit harder to understand, if the center of the circle is 3, is only 1 between each one, then you're going to have a circle inside of a circle. The circle with a radius of 3 is going to fit inside the circle of the radius of 5. Okay. Now, there's no solution there as well. If you go to what happens if D is equal to 2, well, then you've got a circle that's going to be on the inside of the other circle, but it is going to touch at one point inside of the circle. Okay, very, very, just at one little bitty point, something like right there, it will touch. Okay, so you're going to have 1 on the inside of the circle. E says if the value, for which values of D do the circles intersect in exactly 1 point? Well, here we had 2, and the other one was at 8. And if you'll notice, we get those here. That's where they're going to touch exactly once. The radius plus and the radius is minus. Radii, I guess radius. Okay, I don't know. Anyway, for which values of D do the circles intersect in 2 points? Well, when the distance is greater than 2 but less than 8. Okay. Anything outside of that, they're not going to have 2 points. Now, when do they not intersect? Well, either when the distance between the centers is less than 2, or when it is greater than 8. Okay. Hopefully you're seeing that in your head and able to picture that. Okay. Example 2, find the distance between the centers of the two circles with equations below, and use the distance to determine in how many points these circles intersect. Okay. So we're not actually finding out where they intersect, we're just finding out how many times they intersect. So what I would do is, since I know the center of the circles here, and I got that because here they are. Here's this one. Since the negative is built in, then I know that my x is 2 and my other one's 1. Well, here we don't have them. In that top one, it's not x minus or y minus anything. It's just x squared. So I know that it's at 0, 0. And when I plug that into the distance formula, I get the distance from the center is 5. Or, I'm sorry, not 5, the square root of 5. When I work those out, I get it to be the distance is equal to the square root of 5, which means from here to here is 5. square root of 5. I'm getting in trouble with that. Okay? Then I'm going to look at this, and I know that my radius is the square root of 5, and here it is the square root of 3. Okay? Well, if the distance, I didn't draw that one exactly right. If the distance for one of them, the radius is 0.5, and it should actually touch the center of the other one because it has the same radius. The distance between the centers and the distance of the radius there are the exact same. So it should touch the very center of it. And then the other one is 3, and so therefore I know that it's going to touch in 2 places. And we're not concerned right now with it. I bet you we are on this one though, where it's actually touching. Use a distance formula to show algebraically and graphically that the following 2 circles do not intersect. So this is going to be a 0 solution, no solution here. So let's look at it. So what's going to be the best way to do this? Let's take the center of the circles and find the distance formula there. So this one is 1 and -2. And then this one would be -5 and 4. Since the negatives are built in, you got to know what you're looking at. Now, distance formula. Square root of, let's start with the bottom one. This x is -5, and that's going to be -1 squared plus 4 plus 2 squared. So -5 minus 1 is -6, which it doesn't matter. 6 squared is 36 plus 6 squared is 36. So that's 72. Square root of 72. Well, we know 6 is a multiple. 6 times 2, or 36 times 2. So 36, the square root of 36 is 6. And we got 2 left over. So this would just be equal to 36 times 2. Factor out square root. All right. So now we have the distance between the center. Okay. Now we're going to have to find our radius. Well, the radius for this one is 1. The radius of this one is 2. So if we add those together, we're only going to have 3. And of course, if we subtract it, it's only going to be 1. And this is going to be greater than 3. So it would not intersect. There would be no solutions for those. Now, let's go ahead and draw it. Try to. -1, 2. That's going to be the center. 5. Wait a second, not -1, 2. It'd be 1, -2, wouldn't it? 1, -2. It'd be down here. There's the center of 1. And then we would have -5, +4, the other center. Okay, and the distance, the radius is only 1, and the other radius is 2. So this is just going to have a radius of 1. That one has a radius of 2. Those would not touch. All right. Now, just a couple more minutes. Hopefully I can get through the rest of it. It says point A32 is on the circle whose center is at C, -2, 3. What is the radius of the circle? Okay, so since I know that point A is on the circle, then I want to know the distance to the center. I'm just going to plug those into the distance formula, and I'm going to have the radius then. Okay, so distance formula. Let's go with x3 plus 2 because of the built-in negative. This -2 becomes a +2 plus 2 minus 3 squared. So 5 squared is 25 plus -1 squared is 1. So square root of 26 is the radius. Okay. All right, what is the equation of the circle? Well, I'm going to take the center of the circle, which is -2, 3, plug into my formula. Since it's a -2, becomes a +2 squared plus y minus 3 squared equals 2. It's going to equal 26 because remember it's the radius squared. So the square root of 26 squared is 26. Okay. That's page. Use the fact that the tangent A32 is perpendicular to the radius at the point to find the equation of the tangent line. Okay. So what we're going to do here, we're going to find the differences. Okay, if that is 3, 2, what you're going to end up doing is having to flip the slope here because it's got to be perpendicular. So you do the opposite. I'm not going to do these last two. It's not going to be on your test, so don't worry about it. And that should, I think that's it. What the equation of the tangent to the circle. All right, so that's all I got to do. Don't worry about those. You're not going to have to worry on those. If you'll know everything that we've talked about up till now, you'll be good on the test.